In the first part of this video, we are going to look at how shape affects the mean and median of a data set. On the left, I'm seeing a dot plot, and these are the data values that were graphed into the dot plot. And as we can see in the title, these values all represent the heights of plants. So some of the plants were 16 inches tall, some were 18 inches tall, etc. I know that the shape of this dot plot is symmetric. More specifically, it's bell-shaped or normal. If I were to use GeoGebra to find the mean and median, I'd see that the mean is 18 and the median is also actually 18. They're equivalent. If you think about it, this makes sense because of the fact that the distribution is symmetric. So the data values are evenly distributed. Let's now look at a different dot plot. Here I'm seeing all the data values represent class sizes. So some of these classes have 28 students, some have 29 students, etc. Notice the shape of this dot plot is actually skewed to the left because most of the data values are near the larger numbers. So there's a cluster on the right-hand side, and then there's a few data values on the left-hand side, causing the shape to skew in that direction. If I were to calculate the mean and median, I would see the mean for this set is 28.25 and the median is 28.5. So the median is actually bigger in this case. This makes sense because think about how we calculate median. The median is located in the center of all data values. So if most of the data values are larger numbers, the median is going to be located somewhere in that region. The median will be closer to the cluster of values. Then think about how we find mean. That's the average. That calculation incorporates every single data value. So if we have a handful of values that are smaller, those small values will pull down the mean, making it smaller than the median. The numbers in this third dot plot each represent the age of Gabriella's shirts measured in years. Notice most of the numbers are small because most of the shirts are newer. So we're seeing a bunch of zeros, meaning she's had these shirts for less than a year. We're seeing a bunch of ones, meaning she's had those shirts for a year. We're not seeing a lot of large numbers. Because of that, this distribution is skewed to the right. Notice there's a cluster on the left-hand side where the lower values are located. And then the graph is skewing to the right because we only have a few data values on the right-hand side near the larger numbers. If I were to calculate the mean and median, the mean would be 2.4, the median is 2. Notice in this third example, the mean is actually bigger than the median. This makes sense if you think about it, because remember, the median is going to be closer to the cluster. The mean, on the other hand, is an average calculation of all of the data values. So that handful of larger values are going to pull up the mean. This is a summary of what we just discovered relating to how shape affects mean and median. Whenever we have a symmetric distribution, the mean and median are approximately equal. When a distribution is skewed to the left, the mean is smaller than the median. This is because the median will be close to the cluster of large values. The smaller values in the left tail will pull down the mean, causing it to be smaller than the median. Finally, when a distribution is skewed to the right, the mean is larger than the median. This is because the median will be close to the cluster of small values. The larger values in the right tail will pull up the mean, causing it to be larger than the median. In the second part of this video, we are going to compare measures of center and measures of spread. Then we're going to determine which measure is better based on the shape of a data distribution. Here we're seeing a random sample of company employee salaries measured in dollars. I used GeoGebra and found the mean is $93,611. The median is $65,808. The standard deviation is $65,864. And the IQR is $49,992. Let's say we took out the outlier. You might have noticed one of the salaries is much larger than the rest. This salary might be the CEO's or another top executive in the company. And that salary was $272,500. We're going to recalculate the measures of center and measures of spread. When we do that, the new median is not that different. It's 65,270. The new IQR is a little lower, but again, it's not that different. It's 34,316. Now let's see what happened to the mean and standard deviation. They drastically changed. Notice the new mean is 73,735. And the standard deviation drastically dropped to 20,872. This means that outliers or extreme values, really low numbers or really large numbers in the data set, have a huge impact on the mean and standard deviation. Because of the fact that the mean and standard deviation were so drastically impacted by a single number, they would not be the best measures to represent this data set. In conclusion, if data is symmetric, the mean and standard deviation are the best measures representing the data set. The mean is the more appropriate measure of center, and the standard deviation is the more appropriate measure of spread. Remember, this is not the case if the data is skewed. In that case, the median is a more appropriate measure of center, and the IQR is a more appropriate measure of spread.